Hi, this is Alex from devstories.eu. MicroPython, Episode 3 of 7. Forget the tedious compile, flash, and reboot cycle. You change one variable in a typical embedded project, wait minutes for a build, write to flash memory, and hope it works. MicroPython entirely bypasses this by letting you talk directly to the chip in real time. This episode covers live coding the MCU using the REPL and mpremote. The REPL stands for Read Eval Print Loop. It is an interactive prompt running directly on your microcontroller. You connect your board over USB, open a serial terminal, type Python code, and the chip executes it instantly. The standard REPL is designed for humans. It provides auto indentation, command history, and basic auto completion. It is perfect for testing a quick hardware pin toggle. However, there's a second mode called the raw REPL. People often confuse this with a limited version of MicroPython, but it's actually just a different input mode triggered by sending a specific control character over serial. The raw REPL disables character echo and auto indentation. Tools use the raw REPL to programmatically inject large blocks of code into the microcontroller. If a script tried to paste text into the standard REPL, the human-friendly auto-indentation would cascade and completely mangle the Python formatting. The raw REPL guarantees the code goes in exactly as written. This brings us to mpremote. This is the official command line tool for interacting with MicroPython devices, and it drives the raw REPL under the hood to perform heavy lifting. For live coding, mpremote offers two powerful commands, run and mount. You use the run command to execute a local script from your computer directly on the board. You write your code in your favorite text editor, open your terminal, and invoke mpremote run followed by your file name. Here's the key insight. The code is sent over the serial line and executed entirely in the microcontroller RAM. It is never written to the flash memory of the device. If you write a bad loop and crash the board, you just hard reset the chip. The flash remains untouched, saving write cycles, and your development loop takes seconds. When your project grows beyond a single script, you use the mount command. This command tells mpremote to take a local directory on your PC and map it over the serial connection. The microcontroller temporarily overrides its own storage and treats that folder on your computer as if it were its internal file system. Consider a scenario where you're writing a complex display driver. Usually, you would have to copy the driver file to the board, run your main script, observe a screen glitch, edit the file on your PC, and copy it over again. With the mount command, the microcontroller executes the driver directly from your PC's storage. You hit save in your text editor on your laptop, restart the script on the board, and the changes apply immediately. You iterate as fast as you can type, completely eliminating the flashing step from your workflow. The true power of MicroPython is not just the Python syntax itself, but how tools like mpremote erase the boundary between your local development environment and the physical embedded hardware. That's all for this one. Thanks for listening and keep building.